So let's say you have a function in terms of y, and we call that function g of y. And g of y bounded between these two lines, y equals c and y equals d. Okay. So this is the region Q that we're looking at. So this region Q. And then we rotated this about the x-axis. So then we get this figure. And I'm not very good at drawing rotation. But bear with me. Okay. And so then you will get this figure. Okay. So if now you slide in your cylinder, then the height of your cylinder is the function g of y, and the radius is vary between c to d. Okay, so then the same formula apply. However, we have to evaluate this in terms of y. Let's take a look at an example. Let Q be the region bounded on the right by the graph of g of y equal to square root y, and on the left by the y-axis for y is between 0 to 4. We want to find the volume of the solid generated by revolving Q around the x-axis. So let's take a look at make a rough sketch of what it looks like. Okay. When y equal to 0, g of y is equal to 2 times root 0, that equals 0. When y equals 4, g of y is equal to 2 times square root of 4, that now equal to 4. So when y equal 4, x equal 2, okay, and it's bounded between 0 to 4. So this is the region that we are looking at. Then we go ahead and rotate it about the x-axis. So you get this figure. Okay. So then we can use this formula to calculate the volume. The volume equal to 2 pi times the radius. The radius vary between 0 to 4 of the function, that is 2 square root y dy. So then we have 2 pi integral from 0 to 4 of 2 times y to the 3/2 dy. So evaluate this integral. So you're looking at 2 pi, 2 times. So 3 over 2 plus 1 make 5 over 2. So this is 2/5 times y to the 5 over 2 evaluate from 0 to 4. Let's clean this up a little. 8 pi over 5 times 4 square root of 4 to the 5th. That is a pi over 5 times 32. And that is so we talk about the volume of the figure rotating about the x and y axis. What happens if it rotates about a different line? So for example, we want to find the volume of the region enclosed by the x-axis. The parabola y equal f of x equal 3x minus x squared revolve about the vertical line x equal -1 to generate the solid. So let's start with the graph and we'll see what it looks like. So 3x minus x squared have the x-intercept at x equal to 0 and x equal 3. And so we have this parabola looking like this. And we rotate it about the line x equal to -1. So this is our line of rotation. So then we, on this side, we get that figure when we rotated this. Okay, so this is the figure that we get in. Okay. So note that now the height of our cylinder is still f of x. However, the radius of that cylinder, wherever that is, it is x plus 1. So here you already have 1 unit, right? And wherever this x end up to be, this whole distance have to be x plus 1. So that is our radius. So here we know that the radius is x plus 1. Okay. The height is still f of x. So then the volume is equal to 2 pi and the integral from 0 to 3. The radius is x plus 1. The height of that, the height is f of x. That is 3x minus x squared dx. Evaluate this integral we get. First, we expand this out and combine like terms. So then we have evaluate from 0 to 3, and this equal to 45 pi over 2. In the next problem, we look at the region bounded by the graph of two functions. Okay, R is defined as the region bounded by the graph of the function f of x equal to square root of x. Below, by the graph of the function g of x equal 1 over x over the interval 1, 4, and we want to find the volume of the solid that generated by that by rotating that region. So let's go ahead and draw the graph to see what it looked like. Okay, so square root of x, like that. Okay, so 1, 1, when x equals 4, y equals 2, and square 1 over x is the graph that looks like that. And we want this to be, the region is in between 1 and 4. So this is the region that you're looking at. Okay. And we then rotate it about the y-axis. Okay. So this saying that the height of the cylindrical shell is the difference of f of x and g of x. Okay. So the height is the difference of f of x and g of x. So the volume is equal to 2 pi times the radius, that is between 1 to 4, multiplied with the height of the cylinder, that is square root of x minus 1 over x dx. We simplify this to get evaluate this integral, we get 94 pi over 4. Excuse me, 94 pi over 5. So we have talked about a couple methods of calculating the volume of the solid. So how do you then decide which one to use when given a region? So let's take a look at this. You want to use this method when you're given a graph that the solid have no cavity in the center. You use the washer method if the center is kind of hollow for that solid. And you want to use shell method with, you can use that with either there is a cavity in the center or not, right? So it's entirely up to you to use what method is best. The shell method will apply to pretty much anything, depend on what region you rotate in, what what is the axis of rotation that you then decide whether you are evaluating with respect to y or with respect to x. So this method you will use when you rotate in, when you draw the rectangle, it lays vertically, okay, and you use the washer method when you have the cavity in the center.